Have you ever wondered why, when your code is perfect and your logic is amazing, but in production your app just stops and it freezes for 5 full seconds? And the thing is, you didn't write a bug, you didn't leak memory or anything else. And the problem is that you let the JVM make a choice for you. Most Java developers are using the wrong garbage collector. And the problem is they are killing their performance. In this video, we're gonna check each of the garbage collector and how to fix this problem. Hi everyone, my name is Ricardo and welcome to my channel, Programming in Java, where you can watch everything related to the Java ecosystem. And today we're gonna diving into one of those topics or problem that separate those developers that just code and the developers that actually understand the technology. And we are talking in this case about the garbage collection. And probably you now are thinking, but Java handles the memory for me. Why the hell should I care? Well, the thing is, Java is pretty nice and it's managed the memory for you, but of course it's in free. It's like having someone that is cleaning your house, but then when it's cleaning your house, you want in a specific time to be cleaned and not when you have friends at your place. Maybe it's a bit stupid example, but just to make you think like how it works. So at the end of this video, you're gonna to understand the 4 main garbage collectors. Whether you are building a tiny microservice or massive big data pipelines or even a desktop app, just stick around because I'm gonna explain you how to optimize your Java application. If you are still using the same flags that you used in Java 8, you are leaving performance on the table. But let's get into it! Alright, let's talk about the nightmare every Java dev has faced at least once. Probably even you. Just imagine that you're having a coffee and then you're looking the logs on production about your app and everything works perfectly. Everything is smooth, the response times are under 50 milliseconds, and then you notice something. There is a small gap. For 3 or 4 seconds, nothing happens. There is no logs, no requests, nothing. And then the app wakes back up like nothing happened. And that has a name. And the name is Stop the World Event. And the thing is, when the garbage collector needs to clean up memory, it often has to pause your application threads. And the thing is because it needs to make sure that no one is moving objects around while it's trying to sweep them up. As you can see, there's like small trade-off in the JVM. Throughput versus latency. Throughput is basically how much work can my app do in total. For example, if your app runs for an hour and I spend 9 minutes doing work and just 1 minute cleaning, that's a really high throughput. But latency, on the other hand, is how fast does a single request finish. And to make you and just to give you an idea, just imagine that you're running your app and you have this minute, but this minute is cleaning everything all at once. So your throughput is high, but your latency is terrible for that 1 minute. So it's not maybe like a trade-off that you want to do it. And here is the big misunderstanding that many of you probably are doing. A Java developer sees that the app is slowing down, so they think, maybe I should just give them more RAM. And you move from 4 GB to 16 GB, and for a while, it may fix the problem. And the pauses happen less often. The problem is that now, when the pause happens like massive, like it takes huge amount of time. And you wonder why. And this is basically because the garbage collector now has 16 GB of memory to scan instead of 4. So probably just increasing the RAM or the memory is not the best and optimal solution. And depending on which kind of garbage collector you're using, it makes your stop the wall pause longer. As you can see in a correlation, imagine that you need to clean your trash at home. You don't have to do it often, but when you do it, it takes the whole day. And as always, stop just throwing hardware and start choosing the right tools for the job. And here comes the question again. How do we choose? We have to look at how this collector actually works. So then let's break down the big four collectors. First up, we have the serial GC. You enable this with this param. The serial GC is the loaner. The serial GC uses just a single thread for all its work. When it needs to clean the memory, it stops everything and uses one single CPU core to do it. But of course, that could sounds strange. Nowadays, we have 64 core processors, even more, so it could sound terrible idea, right? Not really, it depends. If you are running a teeny container or application that is very small, for example, a CLEA tool with less than 15 megabytes of RAM, it could be amazing for these cases, because having multiple garbage collector threads, it may be more expensive than just letting one thread do the work. And it's basically simple and lightweight. Just don't use it in your high traffic web server. Here comes the next one, number 2. We have the parallel GC that you activate that with this param. Back in the Java 8 days, this was the king, and it was the default one for a long time. As the name suggests, it used multiple threads to perform garbage collector. And its goal isn't to make posts short, its goal is to make them efficient. It wants to make sure the total time spent collecting is as slow as possible. If you are running a really heavy processing job, like processing a big text file, you don't care if the app freezes for 2 seconds. You just want the whole job to finish as fast as possible. If the throughput is your only metric, parallel GC is still a fantastic choice. But then after that, Java 9 came along and gave us G1, or garbage first, and it has a completely different mentality about how to clean the memory. G1, or garbage first, breaks the heap into 100 small regions. It tracks which regions are the most full of garbage and cleans those first. That's why the name is garbage first. The cool thing about garbage first is that you can give it a target. For example, you can say to the garbage first, I want max pulse time to be 200 milliseconds. And the garbage first will try to do the best to tune itself to meet that goal. It's mostly like the balanced choice. It's the default one in the Java modern versions. It can handle large heaps much better than parallel GC because it doesn't have to clean the whole heap at once. It just cleans enough regions to stay under your post time goal. For 90% of the application out there, garbage first is the right answer. But what about the other 10%? What if 200 milliseconds is still too slow for you or for your application? For example, let's imagine that you are building a high-frequency trading platform or even a real-time gaming server. And this is where CGC enters. And you can enable it in this way with this param. And this garbage collector is a low latency collector. We are talking about sub-milliseconds post times. Whether your heap is 8 GB or 8 TB, this garbage collector post time stays roughly the same. But you may wonder, how does it work? And it's because it does almost all the work while your application threads are still running. It uses something called colored pointers and load barriers. Basically, every time that you call threads to access an object, this garbage collector does a tiny check to make sure the object isn't being moved. The trade-off, since it's doing all this work while your app is running, it uses more CPU. So you may see a 5 to 10% drop in raw throughput because the garbage collector is stealing CPU cycles to stay quiet. So not everything is free here in the Java world. But for many, that's a price worth paying to never see a 5-second freeze ever again. And here I'll let you a benchmark where you can see the difference between memories and the garbage collector. So check it out and do your own research. But let's wrap this up. Garbage collection isn't some scary monster or something that you need to be scared of. Garbage collector, as you can see, is nothing that you need to fear about. It's something that is a tool that you can master, and in this video, and of course, it's not just about cleaning up trash. It's about managing the ability and the heartbeat of your application. We looked at serial GC for the small stuff, the parallel GC for the heavy lifting and high throughput, garbage first or G1 for the balanced, and CGC for the high performance, ultra low latency requirements, for example, as a real-time video game or trading, as we said. As you can see, a single JVM flag, chosen correctly, can be the most effective optimization that you ever make in your application. But now, after this video, you have the knowledge to look at the performance bottleneck and know exactly which lever to pull. And that, my friend, that's the difference between a dev who just write code and a dev who understands exactly the technology. So congratulations if you watch the whole video. I want to hear from you. What kind of garbage collector are you using in your application in production? Have you ever heard about any of those? Or do you have any question that I could answer to you? Drop a comment below and let us know what are your thoughts. And of course, if this video helped you to understand a bit more about the Java virtual machine, just hit that like button, share it with a colleague, and it helps me a lot to even motivate to continue to create videos. And of course, subscribe. And that's pretty much it. Here you can find some more videos in my channel. I hope you enjoy it, and we see us in the next video. Ciao!